So hello guys, good morning, good evening, good afternoon. So today we are going to continue again Linux fundamentals, specifically focusing on Linux permission and process management. And we already started file permission yesterday, and we are continuing file permission today as well. And once we completed file permission, we will start process management. Yeah, so that is today's plan, and I will share the necessary resources as well. And welcome to everyone today's early morning amazing live session. And yeah, let's start around 4:30. Thank you. So guys, we'll start 4:30 am now, and yeah, so we are continuing studying the Linux basics, specifically file management and process management. And welcome to everyone. Let's start.
List the files. And using this command, you can see all the files and folders on this particular environment or in the particular directory. But if you watch carefully, this particular string, all the strings have the first word in common, right? You can see there is a unique pattern RW blank, RW blank, RW blank, RW blank. So this particular word represents file permissions on the files or the folders, right? So this is the one that decides permissions on files and folders on the Linux server. But Abhishek, what exactly is this? If I write this down, so the permissions on the file, on the first file is blank, RW blank, RW blank, followed by R blank blank. So the first character here represents if it is a file or a directory, right? So this is the only directory here. Test is the directory that I already created in TMP. That's why you see instead of blank a character called D. That means if it is a directory, you will see a character called D. Otherwise, you will see blank. So the first character of this word represents if it is a file or a directory. Okay, leave this aside. Then there are 9 different characters. 1, 2, 3, 1, 2, 3, 1, 2, 3. These 9 characters can be split into 3 sets. Set 1, set 2, set 3. And each set represents permissions of different things. So the first set represents the permissions of user. Second set represents the permissions of group. And the third set represents permissions of others. But Abhishek, what is this user, groups, and others? Very simple. User is the one that created the file. In this case, user is developer. So developer created this file called helloworld.sh. So user is developer. Group is nothing but the group that developer user belongs to. In previous episode, I told you the advantages of group. Basically, users are put inside group so that you can control the access at the group level. So basically, bunch of users are put inside a group or bunch of users make a group. For example, all the developers are put in a group called dev. All the QA engineers are put in a group called QE. Now these permissions are for the group of the developer. That means dev1, dev2, dev2, right? Dev-n, whoever are the developers that are part of this group, along with the user called developer, they get access which is defined here. Now finally, others are the ones that are other Linux users on the Linux file system that are not part of the developer group. In our case, QE user is other user because QE user is not part of the developer group. So that's why Q user had less access. But Abhishek, what is this RW hyphen or RW blank, RW blank, and R blank blank? Very simple. The 3 characters in each set represents read, write, execute. These are the 3 actions, right? Read action, write action, execute action. So in each set, you will find read, write, and execute characters. If there is a blank for any of this character, that means that permission is missing. Now, if you try to understand this particular permissions, user that created the file has the read access, write access, but not execute access. Abhishek, what is write? Write is nothing but updating the file or modifying the file. Read is nothing but reading the file. And execute is basically executing the script. In our case, executing the shell script. So the first set here says the user has read access, write access, but missing execute access. Group that the user belongs to has the read access, write access, missing the execute access. And others, that is every other user on the Linux server, has the read access, no write access, and no execute access. What I did, I removed the read access as well. That's why on the hello world.sh, when you look at other files, queue user, if I go to the queue user and if I do cat, let let's say this file called Abhi, right? I'm able to read the contents of Abhi file using Q user. Similarly, I can read the content of Veeramalla file as Q user, but I mean, it's a blank file. I'm able to read it. But when I try to read hello world.sh, it says permissions denied. That is what I did using the chmod command. To demonstrate you how file permissions work, I used the chmod command that removed read access to the QA user as well. You will find part of the user groups and other. So the permissions, you will see the same thing. I should not be able to update it. Okay, script called hello world.container environment using the Q user. It's very simple. You can go to your terminal, click on shell, click on new tab, and a new tab is created. Most of the terminals support this. If it doesn't support, you can take two different terminals. Okay. Now, using the developer user, I will get into the TMP folder, and here I will create a script called hello world.sh. Let's write within the script insert mode, shebang, bin bash. I'll write a very simple hello world. It doesn't matter if you are writing a shell script, Python, or text file because the concept is same. And I'll save the file using escape colon WQ exclamatory. Okay, let's verify if the file is created. Hello world.sh is created. Perfect. Now let's go to the QE user. I'll go to TMP folder. Can I see the file? Okay. I see the file called hello world.sh. Can I read the file? Cat hello world.sh. Perfect. I'm able to read the file as I explained during the theory part. Now let me see if I can update the script file. Ideally, I should not be able to do it because developer created the script. Developer knows the script. As a QA engineer, my knowledge to script is very limited, and because that's a script of someone else, I should not be able to update it. Okay, so enter a new line. Let me write some random string and I will try to save the file. Instantly, Linux file system or operating system throws an error saying can't open the file for writing. That means as a QA user, enter a new theory part. Now let me see if I can update the script file. Ideally, I should not be able to do it. Because developer created the script. Developer knows the script. As a QA engineer, my knowledge to script is very limited, and because that's a script of someone else, I should not be able to update it. Okay, so enter a new line. Let me write some random string and I will try to save the file. Instantly, Linux file system or operating system throws an error saying can't open the file for writing. That means as a QA user, you cannot update the file. If I still do cat as a QA user, you cannot update the file. If I still do cat hello world.sh, you will see the same thing. Echo hello world. Not permitted. So this proves that Linux by default comes with file permissions, or there are default file permissions that is set up by Linux on every file